All rise for the triumphant return of the greatest space show on the entire solar system. It's me. Join me to explore the greatest show on the solar system right here, in which we follow the fortunes of humanity's robotic missionaries to the Red Planet. This week, we take in the spectacular liftoff of the Phoenix spacecraft on its long journey to Mars, where it will search for signs of life in the frozen north. It is July 2020, and after years of development, testing, and setbacks, the Phoenix Mars lander is finally ready to fly. On board are several instruments that will study the planet's climate and atmosphere, soil composition, and surface features, looking especially for signs of past or even present-day water and potentially habitable environments. The craft will also be carrying an American flag and a plaque dedicated to essential workers around the world who are working tirelessly to combat the COVID pandemic. After a nail-biting launch window, Phoenix successfully lifts off from Florida's Cape Canaveral on a United Launch Alliance Atlas V rocket at 7:58 p.m. Eastern Time on Sunday, August 16th. It's a moment of elation for the team after many years of hard work and some frustrating delays. "I can't believe we're actually going to Mars," beams project scientist at JPL. "It's such an amazing feeling. We've been working so long for this, and I'm just really happy that all of our hard work has paid off and we're actually on our way to Mars." Liftoff was spectacular, with the most powerful rocket in the world doing what it does best, shooting a payload into the sky from which there was no hope of return. No wonder one of the first messages sent by the Phoenix team was a simple, "We're in space." Phoenix will reach Mars in February 2021, landing in the northern hemisphere in a region called Utopia Planitia, a vast smooth plain dotted with mysterious pits and troughs. Its principal investigator, Linda Ka, describes the landing site as breathtakingly beautiful. Selected because it looked like the best place to land and do science, Utopia Planitia is located just 10 degrees north of the Martian equator. Like much of the northern hemisphere, it is heavily cratered, but distinguished by its relatively smooth and flat terrain, an indication of past resurfacing events. Some scientists think it may have once been covered by a vast ocean. Others suggest it could be the result of massive volcanic activity. Whatever its origins, scientists think the area may hold clues about the history of water on Mars and the possibility of past life. But why send a lander to Mars in the first place? Why not use rovers like Curiosity and Perseverance, which have the advantage of mobility? Because there's a lot that a lander can do that a rover cannot. And besides, says Jim Watson, director of the Mars Exploration Program at NASA headquarters in Washington, D.C., "We like to have multiple lines of evidence. There are basically two reasons we land things on Mars," he explains. One is to put instruments on the surface that are far more capable than anything you could put on a rover. The other is to be able to go to places that are difficult for a rover to reach. The Phoenix mission has three main scientific goals. First, it will look for organic molecules, the building blocks of life as we know it. Second, it will study the modern Martian climate and atmosphere. Third, it will investigate the history of water on Mars, including whether it ever existed in liquid form and whether it could have supported life. The organic search is being led by scientists at JPL, who will use the mass spectrometer on board the Phoenix to sniff out any interesting chemical compounds in the soil and rocks at the landing site. In particular, they'll be looking for amino acids, which are the building blocks of protein and are considered a key indicator of biological activity. To date, only one other mission has looked for organic matter on Mars. In 2014, NASA's Curiosity rover found some, but the discovery was somewhat controversial. Scientists couldn't agree on whether it came from ancient life or non-biological processes. This time, though, the team is confident they'll find something. "We're going up north to an area that has not been explored before," says Paul Geithner, an instrument scientist for the mission. "And we're specifically going to an area that's been covered in ice at some point. And so we expect that if there are organics in the top layer of the soil, we will find them." Curiosity is still on the move, but scientists say it has already revolutionized our understanding of Mars. After exploring the bottom of Gale Crater, the rover has climbed up the crater wall and is now on a new mission to reach the top. But before it gets there, it may make another significant discovery. On August, Curiosity transmitted a photo taken by its Mastcam Z camera showing a curious object sitting near its tracks. It looks a bit like a tiny metallic box, almost as if something had been dropped or abandoned in the dust. But don't worry, it's probably just a rock. Curiosity's mission was originally planned to last 2 years, but it has been extended through 2023. It has already driven over 28 kilometers, 17 miles, more than any other rover in history. But how does it compare with the upcoming Perseverance rover? Perseverance is a larger, more complex machine with a nuclear battery instead of solar power and a sample return system to collect and seal up to 43 samples of Martian rock and soil. Perseverance will carry several instruments to hunt for signs of ancient life, including a device called SuperCam, which uses a laser to vaporize rocks and identify their chemical composition. It will also have a drill to extract core samples up to 2 inches in diameter and a set of cameras to take high-resolution photos of rocks and other objects. It's fair to say then that while Phoenix will have plenty of scientific capability, it won't be quite the same as Perseverance. But it will be carrying a unique instrument called the Thermal and Emitted Properties Spectrometer, or TEPS, which will measure the heat emitted by rocks and soil in order to identify their mineral composition. One of the primary goals of the Phoenix mission is to understand how the Martian climate and atmosphere interact with the surface. The idea is that by measuring the temperature and composition of the rocks and soil, scientists can learn more about the gases and dust in the atmosphere and how they interact with the surface. This is important because the atmosphere is constantly changing, both in the long term and in the short term. In the long term, the atmosphere has lost most of its carbon dioxide over the past 4 billion years, resulting in a runaway cooling effect that turned Mars into a frozen desert. In the short term, dust storms can rage across the planet, blocking the sun and causing temperatures to plummet. Scientists want to know how these changes affect the surface of Mars and whether they might have played a role in the planet's habitability. We really don't know what the climate has been like on Mars in the past, says William M. Farrell, professor of planetary science at the University of Arizona and principal investigator for the mission's atmospheric escape and interaction studies. So one of the things we're trying to do with Phoenix is to help us better understand the climate system on Mars, so we can better interpret the data that we've been getting from other missions. To do this, Phoenix will measure the temperature and pressure of the atmosphere, as well as the amount of carbon dioxide in the air. It will also study the interaction between the atmosphere and the surface, such as how dust is lofted into the air and how water vapor condenses into clouds. Finally, Phoenix will study the history of water on Mars. The evidence for past water is all over the planet, from ancient riverbeds to giant canyons to huge volcanoes. But scientists still have many questions about how water shaped the surface of Mars and whether it ever existed in liquid form. If it did, then there is a chance that life may have evolved under the red planet's thin atmosphere. But to find those answers, we need to go to the poles, says Sylvester Morris, principal investigator for the French space agency CNS. The poles are the only places left on Mars where there is still ice on the surface. And we think that the ice may preserve a record of the planet's history. To study the ice, Phoenix will use a scoop on its robotic arm to dig through the surface and analyze the composition of the ice. It will also use a pair of cameras to image the surface in color and take high-resolution panoramic photos. So those are the 3 main goals of the Phoenix mission. If all goes well, we'll hear more about them soon. And who knows what else Phoenix might find? After all, it's only the 2nd mission to explore the North Pole. No one knows what we might find there. And so the team waits with bated breath for their spacecraft to arrive at Mars. Landing on another planet is always a fraught affair. Everyone knows that things can go wrong, but after all the years of hard work and planning, hopes are high. I feel very confident about the landing, says Jim Watson. I think the team has done an incredible job getting this vehicle ready for flight and for landing on Mars, and we've got a great deal of confidence in our simulations that we've done. But no matter what happens, the team is already looking forward to the next mission. As Sylvester Morris says, we know that this is the beginning of a new adventure. And we're all very excited about it. That is the end of today's episode. All the best to the Phoenix team. Thanks for watching. If you enjoyed this video, please subscribe for more updates. There's a full playlist of videos covering every episode of the greatest show on Earth.